Hello all. Previously we have seen how to add a node at the beginning of the linked list. Now in this particular video we are trying to add a node at the end of the linked list. Now let us see how to add a node at the end of the linked list by using a function called insert@end that will accept a node value as a parameter or input value. So as a first step, we have to create one node called temp that will be having two fields. One is data field and another one is next field, which is the address field, as we already aware. Now the next step would be, so whatever the x value, so let us say the x value is 40. So 40 will be assigned to temp data part. So the first part will be assigned with 40 value. Okay, that is the meaning of it. So whatever the temp next. So why we are assigning null here? Because we are working with a function called insert@end. So whatever you are going to add a node, that will be the last node. So that is generally the next field will become null only, right? So that is the meaning, that is the reason we are having the null value is assigned to temp next part. Okay, so in worst case, let us assume there are no nodes in the linked list. That means the head is pointing to null. In that case, whatever you are going to add a node, that will become the first node, right? That will becomes the end node itself. So initially let us assume the head is pointing to the null. So whatever you are going to create a node, that will becomes the last node, right? Or first node, right? So that is the scenario here. So if head double equal to null, if that is the case, so whatever the address of temp, that will be assigned with head. So head also pointing to the temporary node. So that temporary node will becomes the first node. That is the meaning of it. Once it is done, we have to return. And that means the function is over. Since this is the void function, we are not going to return a value, but we are ending this function with this return statement. That is the meaning of it. Okay. For example, let us assume there are multiple nodes. So head is pointing to the first node. So in that case, what will be the scenario? Now we have to see that particular scenario. So for that, we are taking one pointer called last that will be initially assigned with head. So that is what is the meaning here? Last and head both will be pointing to the first node itself. So by this loop, we are performing the traversing. So after this loop, the last pointer will move to the last node of the linked list. After that, whatever the new node which you have created, that address will be assigned to last next. So that the new node will be assigned to the previous last node. That is the meaning of it. So enough of theory. Now let us going to track this working procedure so that you will have a better picture. So let us try to assume the things for the tracing purpose. Now let us assume the linked list as follows: 10, 20 and 30. Don't worry about this diagram, just mention here, but assume this is not there. Okay, so now let us assume we have called insert@end function with a parameter 40. Okay, so initially the head is pointing to the first node. So first creates a node by the help of malloc function with the size of structured node. So this node is got created now. That is the temp. Okay, now whatever the x value is 40, that will be assigned to temp data. So here 40 will be assigned here. Okay, in this part, what I am highlighting now, that will be assigned with 40. That is the meaning of this line. So you are creating a node with the help of insert@end function. So that node will becomes the end node. So the end node next address should be null, right? So null will be assigned to temp next. This is the temp, this is the next part. This next is assigned with null value. Okay. Now I'm not going to check the condition. If head is equal to null, then that node will becomes the head node. That particular check is not required now, because we are having 3 to 4 linked list here. So that's why I have not mentioned here, but in the code we have to mention. Okay, so for example here 3 linked lists are there, right? 3 nodes are there, right? So that is why I didn't write that condition. If head double equal to null, that condition I didn't write for the tracing purpose at least. Okay, but you should write as part of coding. Now we will create one more pointer that will pointing to the head node by the help of this line, struct node last pointer. So whatever the head node address will be assigned to last node. So by the end of this line, the diagram is as follows. The both head and last will be pointing to the first node itself. Okay, now we have to traverse the last part, right? How we can do that? With the help of while loop. So while last next not equal to null. What is the last next address? Last next is 200. Is 200 not equal to null? Condition true. So in that loop we have created one line. I mean we have written one line. So last is equal to last arrow next. What is the last arrow next value? Last arrow next value is 200. That 200 will be assigned to last. So that means last will be pointing to the 200th location now. So by the end of this first iteration, the last pointer will be moved to the 200th location. That is the meaning of it. Okay. Now the second iteration is going to be started. So what is the last next address? So last next address is 300. Is 300 not equal to null? Condition true. Now last should be moved to the next node. How to do that? Last is equal to last arrow next. So what is the last arrow next value? Is 300. So last will be assigned with 300 value. So now last will be pointing to the 300th location. So the diagram is as follows. So last is pointing to the 300th location. Okay. So now last next is null. Now last next is null means I mean the condition is false, because the condition is false. Last next null. Last next value is null only, right? 300 last next is null is right. So null not null, the condition false. So by the end of this loop, last is pointing to the last node. That is the meaning of it. So we have reached to the last node. Now after this loop, we are having one condition. I mean one line. Last arrow next is equal to temp. So what is the temp address? 400. 400 will be assigned to last next part. So this null will be replaced with the temp address. So 400 will assign here, so that the link will be formed. So that is the meaning of it. So 400, what is the temp value? Is 400 here. Previously the temp value is 400. That 400 is assigned with the last next part, so that the link will be formed. So this is how we can add a node at the end of the linked list. So what is the time complexity? Since we have used this with the while loop, based on the number of nodes, we have to traverse with the number of nodes, that there is a dependency with the input size, right? So the worst case time complexity to add a node at the end of the linked list in this approach is order of n. Okay, so there is a better approach to add a node at the end of the linked list with the order of 1, that is constant time. For that we will be needing a temporary point. I mean we will be needing a tail pointer. That will discuss in the further lessons. Now let us try to execute this code. So I have written this code entirely in this dev.cpp. So we are adding 3 nodes, 30, 20, 10. That means 10, 20, 30 is the linked list. Now we are adding a node of 40 at the end of the linked list. So let us try to execute this code. Execute, compile and run. So 10, 20, 30, 40 and followed by null. So that is the working nature, so that in this fashion we can add a node at the end of the linked list. Thank you so much for watching.